Hello, today I'll be explaining how covalent bonding is formed and how to draw Lewis structures, how to determine the shape and the reason behind covalent bonding. So I've specifically chosen four structures today. The first one is called carbon tetrafluoride. Let's look at the naming schedule. It says carbon tetra, the word tetra in front here means 4. So that prefix means 4, 1 carbon and 4 fluorine. The formula for carbon tetrafluoride is CF4, where carbon appears once and fluorine 4 times. Let's quickly look at carbon and fluorine from the periodic table. Carbon has these two numbers 6 and 12 and fluorine has 9 and 19. 6 with 6, carbon has 6 electrons. The electronic configuration is 2, 4, 2 maximum in the first shell and then 4 electrons in the second shell. Now looking at this last number, that is what we are always going to consider when we are going to draw Lewis structures. That last number is going to tell us how many electrons are present in carbon's last electron, that happens to be the second electron. How many more does it need to make it 8? So the golden rule in chemistry is an atom has to be stable if it is going to occupy its last shell with 8 electrons. So the last number is 4, it needs 4 more to make it 8. So regarding carbon, I know definitely carbon will form 4 bonds. The possibilities of carbon forming 4 bonds are 4, but we will look at what carbon is bonding with. The next element is fluorine. So fluorine 9 and 19, 9 is the number of electrons on fluorine. The electronic configuration is 2, 7. Now looking at 7, 7 is really close to it. It just needs 1 more electron to make it 8. So fluorine just needs 1 more electron and carbon needs 4. Therefore fluorine and carbon will come into a mesh. And I have written here that carbon occupies the central position as it appears the fewest number of times in the formula. Carbon just appears once. So I placed carbon in the center. We always start drawing covalent bonding, the Lewis structure, the cross dot diagrams, by drawing the central atom and then working outward. Therefore, in the geometry, I put carbon in the center, 1 fluorine on the top, 1 at the bottom, 1 left, 1 right. Equally spaced out. Now carbon has 4 electrons. Now we are just going to be concerned about last shell's electrons. Therefore carbon's electrons are dotted 1, 2, 3, 4. And in the space that is equally shared between carbon and fluorine both. And fluorine has 7. I have drawn 6 electrons outside with crosses 1, 2, 3, 4, 5, 6. And the 7th electron is inside the mesh with carbon atom. So at this position, the carbon's shell and fluorine's shell, they share an equal space. So these two electrons are shared in between carbon and fluorine. Now our main aim was to make 8. So let's count the number of electrons in the red carbon cycle. So everything in carbon cycle should be counted, including fluorine's crossed electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Carbon had 4. After bonding, carbon has 8 electrons. Now, that is a problem solved for carbon. Let's look at the fluorine atoms now. Fluorine atom had 7. 1, 2, 3, 4, 5, 6. Let's look at the green circle. This looks like a Venn diagram. Let's look at the green circle. 6 outside, 7th one, and this is the 8th one. I could count for fluorine as carbon's electron for fluorine now. Now, fluorine, all the 4 has 8 electrons in them. So carbon tetrafluoride is much more stable molecule when compared to atomic carbon or atomic fluorine. Sometimes carbon tetrafluoride is also drawn like this, but this does not show us the Lewis cross dot diagrams, how many electrons are shared, or the bonding possibilities that carbon could have. So this shape is called tetrahedral. Tetra meaning 4 and hedral meaning edges or 4 corners, I would say. So 4 corners on carbon. Let's move on. The second one. Second one is called nitroxyl. Nitroxyl is hydrogen, nitrogen and oxygen. I have placed the elements in order. Hydrogen first, nitrogen second and oxygen third, and this is the order I will follow while I will draw the Lewis structures. Let's look at the atoms individually. Hydrogen 1 has 1 electrons. It needs 1 more because hydrogen has just the first shell. The first shell gets fully filled with 2 electrons. Hydrogen just needs 1 more electron to make it 2, my bad. Therefore, hydrogen will share 1 electron with nitrogen. And then let's look at nitrogen. Has 7 electrons. Electronic configuration is 2, 5. With 2, 5, let's look at the last number. 5 needs 3 more electrons to make it 8. Therefore, nitrogen in total will form 3 bonds around itself. Let's look at oxygen. Its electronic configuration is 2, 6 with 8 electrons. Last number is 6. It needs 2 more electrons. So oxygen will definitely form 2 bonds. So I placed nitrogen in the center. Nitrogen has 5 electrons. I very for sure well know that nitrogen will share 1 with hydrogen. Nitrogen needs to have 3 bonds and then 2 with oxygen. Therefore, nitrogen is placed in the center. I have placed nitrogen's electrons as crosses. So 5, 1, 2, 3, 4, 5. 2 electrons on the top. These are the non-bonding pairs. Non-bonding pair. This pair is not taking part in any chemical bonding. Now this non-bonding pair, it gives rise to the shape where it pushes down on these 3 bonded pairs down. After bonding, hydrogen starts to feel the presence of 2 electrons in its shell. I could count nitrogen's crossed electron into hydrogen because it is into the black sphere, the hydrogen sphere. So hydrogen becomes stable. Let's look at oxygen. Oxygen, it will always share 2 electrons inside out of 6. Therefore, it means 4 electrons outside. So 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is also stabilized in this scenario, and the last scenario is, let's check for nitrogen. From 5, did we really make it up till 8? So let's count everything inside the red circle. 1, 2, 3, 4, 5, 6, 7, 8. So within this structure, I could draw it like this as well. Hydrogen with a single bond with nitrogen, because one pair is shared between nitrogen and hydrogen, and 2 pairs of electrons are shared between nitrogen and oxygen. Therefore, it is a double bond. Now let's look at the third structure, that is on the board dichloromonoxide, dichlorine monoxide. So di in chemistry means 2, 2 chlorine, mono means 1 oxygen. So OCl2 is the formula. In the formula, oxygen just appears once and chlorine twice. Therefore, I'll place oxygen in the center. So I'm just showing you how I determine the geometry. When I look at the formula, which atom goes in the center, which goes in the side. So let's look at oxygen again. Oxygen has 6 electrons and its last shell, it just needs 2 more. Let's look at chlorine. Chlorine has 17 electrons. So its electronic configuration is 2, 8, 7. The last number is 7. It needs to be 8. So I need to supply chlorine with 1 more electron to make it 8. Oxygen will always share 2, but I have chlorine 1. Therefore, in the formula, I have placed 2 chlorines around oxygen. So each chlorine will share 1 pair of electron. After sharing 1 pair of electron, each chlorine will start to feel the presence of 8 electrons around its shell, both of them. So 1, 2, 3, 4, 5, 6. 7th one inside the mesh that is being shared with oxygen. So 7, 8. Same thing for the other chlorine, 8 electrons. Now let's count the number of electrons in oxygen's red circle. It should read 8. 1, 2, 3, 4, 5, 6, 7, 8. Now within this structure looks to be bent in shape because these 2 non-bonding pairs on the top are pushing down on the bonded pairs. So these 2 non-bonding pairs on the top are going to push down on the bonded pairs, yielding a bent or a V shape. The last molecule for me to discuss is fluorine. Fluorine's formula is F. 2 molecules of fluorines joined together. So I place each fluorine atom on both the sides. So let's look at fluorine, 9 electrons. And looking at this 7, I need to add 1 more to make it 8. Same thing here. This last number is 7. I need to add 1 more to make it 8. After adding 1 more, both of these atoms, fluorine atoms, need 1 more electron. Therefore, both the fluorine atoms come to a mesh. And their orbitals get mixed, their shells get mixed, and they share 1 electron equally between the 2 fluorine atoms. Therefore, let's count again. I had 7 for fluorine on the red and 7 for fluorine on the green side. So 1, 2, 3, 4, 5, 6, 7th one inside, and I could count 8 for the lead fluorine. It is stable. It feels the presence of 8 electrons around its shell after sharing 1 pair. Let's count the green fluorine. 1, 2, 3, 4, 5, 6. The 7th one is inside the mesh, and that's the 8th one. I could count for fluorine. The green fluorine atom has the presence or feels the presence of 8 electrons. Now, all in all, what we got to remember is what we are trying to do is all atoms on the periodic table except the noble gases, all atoms on the periodic table except the noble gases are unstable. Noble gases are stable. So all atoms on the periodic table, all they are trying to do, if a covalent bond is formed, they will share, and they will make their last shell fully filled. And the golden number in chemistry that I will discuss is up to 8 electrons only. So the key is the last number, which helps me identify how many bonds the central atom or the other atoms around would form.